Hello and welcome to the channel. This is Ricky from Data Mastery, and today we are going to talk about Amazon Athena. So let's talk about Amazon Athena and tries to understand what Amazon Athena is all about and what are its features and capabilities. Athena is a fully serverless interactive query service, so you can use Athena to query the data. Typically, the data can be queried using the standard SQL statements, so you don't have to learn any additional language or any framework. You can simply use SQL statements to query the data. Queries are processed using the Presto engine, so Athena is based on Presto. Data remains in S3, and we use Athena directly on S3 to query the data. There's no need for any ETL or any complex transformations. We can query the data as is. And the metadata, which is data about data, is managed using the AWS Glue catalog. Amazon Athena helps us to analyze the large data sets quickly without managing any underlying infrastructure. Now let's try to understand some of the key features of Amazon Athena. This is fully serverless. As I said earlier, there's no need to provision any infrastructure and there is no overhead for the management of infrastructure. It supports multiple data formats like CSV, JSON, Parquet, ORC, Avro. It supports schema on read, which means schema is defined when the data is being read from the S3 files. It is cost effective because we pay only $5 per terabyte scanned data, and you can further reduce the cost by compressing the data and using partitioning. It integrates well with other AWS services like S3, where it pulls the or reads the data from, and it can also integrate well with QuickSight, which is further used to create some visuals out of the data. It is scalable in the sense we don't have to manage any underlying infrastructure. So whatever the amount of data that you have stored in S3, you can scale Athena to query the data. And we can take one step further by creating the partitions and compression of the data to make it more scalable and highly performant service. You can also reduce the cost if you have well partitioned data. And it is also easy to manage the data which is fully partitioned. So that was all about what Athena is and some of the high level features of Athena. Let's go ahead and do a quick demo. Welcome to the demo. In this demo, we are going to explore some of the features of Amazon Athena and how it integrates with data stored in S3. So in S3, we need to create one S3 bucket where we are going to store the sample data that we're going to explore using Amazon Athena. So I have a bucket called Data Mastery Athena Demo, and I have some sales data.csv file uploaded here. It contains a few rows about the sales data, which is obviously dummy data, not the real one. Now, once you have your data in S3, next thing that we need to do is to set up Amazon Athena. So go to Athena, and we have two ways to configure Athena now. Previously, we were able to use only the query tool, and now it also supports PySpark and Spark SQL notebooks, which are essentially like the Jupyter notebooks that you can use, but this is all managed by AWS. In this demo, we are going to use Query Editor just to use the standard SQL statements against our data stored in S3. Now, one thing that you need to do is to create an S3 bucket where the output of the queries are going to be stored. So if you click on Edit Settings, this is where you need to specify the S3 bucket. So you can go ahead and create a new S3 bucket. Let's call it Data Mastery Athena Query Output. And now you go back here and you click on Browse S3 and select the bucket that we just created. You can also optionally define the lifecycle rules for this bucket, but just for this demo, just going to keep the things as is, no additional configurations needed. Click on Save. Now go to the editor. You can see this notification here. It tells you that Athena now supports type ahead code suggestions. So when you're writing your SQL statements, Athena is gonna suggest to you, to complete the query syntax. So next thing that we need to do is to integrate this Athena with the data that we have in S3. One thing to catalog the data is to use glue schema or glue crawlers to discover the schema of your data, and that will also create the database here in Athena. So that is the preferred way. You can also create the table manually, like you have the data in S3, but the glue crawler is the preferred way, and you can also use the standard SQL statements like create table or create table as select. This can also be used to create the tables and the views manually. So what I'm going to do in this case is I'm going to use the glue crawler and give some details about the crawler. Let's call it sales data. Add the data source. And from data source, we just have to specify the S3 bucket where the sales data is stored. In our case, this is Athena demo S3 bucket. So you can set the crawler settings like crawl all the subfolders or crawl the new folders or crawl based on events. So for this demo, I'm gonna crawl all the subfolders and click on next. So here you have to specify the IAM role. If you don't have any IAM role which is already created, then you can just click on create a new role and let's call it sales data. The lake formation configuration is something which you can use if you have Amazon Lake Formation set up, which is used to build a secure data lake on AWS. The lake formation settings is something which enforces you to use the credentials configured in lake formation itself rather than the IAM role that we just created. Lake formation is something which really helps you to build a secure data lakes, and all that RBAC access and other security related configurations can be defined in the lake formation. So for now, we are not going to use the lake formation credentials, so we just leave it as is. The next thing is to choose a database. So we don't have a database, so we're just going to create one. Let's call it sales and refresh it. You have a sales database here. Table prefix, if you want to put some prefix, you can put it here. Otherwise, it will just crawl the files and then use the file names as the table names. Crawler schedule is gonna be, the frequency is gonna be on demand or hourly, weekly, or you can even set up the cron type expressions or the schedules. Create the crawler. So now we have the crawler created. I'm gonna go ahead and run the crawler. Now what this crawler is gonna do, it will discover the schema from the CSV file that we have in the S3 bucket, and then it is gonna create a table that it will add to the sales database that we just created. And this is seamlessly integrated with Athena. So you don't have to use the create table SQL statements to create the table yourself. You can just use the glue crawler. The other benefit of using glue crawler is to discover the change in the schema. Let's say your CSV file has some additional column, something has been changed. Then the crawler is gonna crawl that thing and it will discover the changes in the schema. Now, once the table is going to be created, it will also generate the DDL for the table. So you can copy that DDL, understand how things work under the hood, and probably leverage that DDL to create the future tables manually yourself. Now you can see that the crawler has been completed. And if you refresh, you see that the one table changed. So we just have one CSV file and it has created a table. Go to the tables, click on refresh, and here it is. So the table name is the S3 bucket name, and we don't have any subfolder in that bucket, so it just used that bucket name as the table name, and then you have the sales as the database. Now, if you go to Athena and you refresh this thing, you see that we have a database which is already created, and we also have a table which is created for us. And if you just click on the generate table DDL, it will generate the DDL glue crawler used to create this table based on whatever the schema discovered. So it discovered that the sales data.csv has something called order ID, customer ID, or a date. So it already used the data type like big int or string, price is double. So you can basically change this as well. But glue crawler is intelligent enough to figure out what data type is suitable based on the data itself. And there are some additional table properties which is configured as part of the schema discovery. Like you can see, there is no compression as of now. Now you can see that updated by crawler, which is sales data. This is the crawler name, and the location is this S3 bucket. And you can also see that the row format delimiter, which is comma, and the input format is text input format, and the output format is a Hadoop Hive. So this gives you a lot of information about how tables are being created using the crawler, and you can leverage the same syntax to create new tables manually if you want to. Now, if you, let's say, want to explore some of the values of the rows in the table, so you can click on preview table, which is going to select the data from sales, which is a database, and data mastery Athena demo is the table. And this is what you see here. So you got order ID, you got customer ID, you got product ID, order date, quantity, price, total amount, and region. So this is like a very easy way, and it like seamlessly integrates with services like glue crawlers to catalog your data. And also, you don't need to move the data anywhere. You just keep the data in S3 and then run the crawler on top of S3 to discover the data and the schemas, and then create the table. Now, whatever the table is created by the glue crawler, that table is gonna something that you can see here. So this is pretty nice and straightforward. And you can run the other SQL, the standard SQL commands. There is no kind of restriction on running the standard SQLs. You can create the joins and whatnot, and you can also create views based on whatever the business logic that you want to put in here. So for example, if I say select region and sum of total amount as total sales from my table, which is this guy, and you can just click on these three dots and select insert into editor, and it's going to insert your table into the editor, and then the group by region. So if you click on this, and now you can see the total sales group by region. So you can run your standard SQL commands on the data that you have. Now, as you see here, we do not have any partition defined on this. Usually partitions are defined based on the date, like year and then month and then day, so that when you want to query the data, and if you have this like the date column in there, it's best to use the partition based on the date. But you can pick some other columns as well. Like in this case, we have a region which is kind of unique in itself. So you can partition the data based on the region. And that way, when you have to query the data, and if the data is fully partitioned, you will get the results pretty quickly. So instead of parsing the entire table, it will just parse the table based on the partition. And if the partition is region, it means it will parse the data based on region. So there was a quick demo on how quickly you can integrate Athena with Glue and S3 bucket, obviously, and start querying the data which is stored in S3 bucket using standard SQL commands. Of course, it provides a lot of additional features, like you can leverage the APIs of Athena to use the similar features in your application, and you can also have support for notebook editors, which further supports PySpark and Spark SQL. So there's another feature that we can leverage. But anyhow, this demo was more of to just an introduction with Athena, what Athena is, how it can be used, and how it integrates with other AWS services. Plus, you don't have to learn any other additional language or something like that. You can simply use standard SQL statements. It supports compression, different data formats like Parquet, Avro, CSV, JSON. So it's a pretty robust tool. Give it a try. Just generate some dummy data and play with that and see how it goes. If you have any questions while you set up this, do drop those questions in the comment section. I'll be happy to answer your questions. But that's it for now, and hope you like this demonstration about Athena. And please do not forget to subscribe to our channel and like this video on YouTube, so that whenever we publish a new video, you will be immediately notified about that. Thanks for watching. Cheers.